Okay, previously we saw the separation of log of sine of x plus iy into real and imaginary parts. Now let's look at log of cos of x plus iy. So let's first take cos of x plus iy, and we know cos of a plus b is cos x cos iy minus sin x sin iy, and we know that cos of iy can be written as hyperbolic cos of y minus sin iy can be written as I sin hyperbolic of y. Okay, so sin x, I bring it to the front, hyperbolic sine of y. Okay, now what do we do? uh, Remember, we can also write cos of x plus iy as r cos theta plus I sin theta. So which is equal to r cos theta plus r I sin theta. So let's equate the real and imaginary parts. So we get r cos theta is equal to cos x hyperbolic cos y. Similarly, r sin theta is equal to I sin x. We don't have to write I when we are equating the real and imaginary parts. And hyperbolic sine y minus. Okay. Now let's square both the sides. We get r square cos square theta is equal to cos square x and hyperbolic cos square y. R square sine square theta is equal to, minus will disappear when squaring, sine square x hyperbolic sine square y. Now, by looking at the left hand sides, we know if we add them, sine square theta plus cos square theta will become 1. Now, let's add these two. So, when we add these two, we get r square sine square theta plus cos square theta will become 1. And let's say sine square x hyperbolic sine square y plus cos square x hyperbolic cos square y. Now, sine square x can be written as 1 by 2 1 minus cos 2x. Hyperbolic sine square y can be written as 1 by 2 hyperbolic cos 2y minus 1 plus 1 by 2 cos 2x plus 1 times 1 by 2 hyperbolic cos 2y plus 1. Okay, now let's multiply half and half, so we get 1/4. Here also we have 1/4, so common, take it out, and we have 1 minus cos 2x hyperbolic cos 2y minus 1 plus cos 2x plus 1 times hyperbolic cos 2y plus 1. Now let's multiply. So 1 by 4, we get hyperbolic cos 2y minus 1 minus cos 2x hyperbolic cos 2y minus times minus plus cos 2x, and then we have plus cos 2x hyperbolic cos 2y plus cos 2x plus hyperbolic cos 2y plus 1. Now plus 1 and minus 1 cancels out. Minus cos 2x cos 2y, cos 2x cos 2y. They both get cancelled. So we are left with 1 by 4. Cos 2y is twice. So 2 times hyperbolic cos 2y, and cos 2x is again 2 times, so cos 2x. Okay, this 2 and 2 is common, we can take it out, and this becomes 1 by 2 hyperbolic cos 2y plus cos 2x. Okay, so we have got r square, so which means r is equal to 1 by 2 hyperbolic cos 2y plus cos 2x to the power of 1 by 2. We have r sine theta and we have r cos theta, right? Let's divide these two. We get minus sine x hyperbolic sine y by cos x hyperbolic cos y. This is coming from here. Okay, so now what do we get? R and R get cancelled. We get tan theta is equal to sine by cos is tan. So minus tan x hyperbolic sine by hyperbolic cos is hyperbolic tan y. And if tan theta is equal to this, that means theta is equal to tan inverse of minus tan x hyperbolic tan y, and this minus can be taken out, so we have tan x hyperbolic tan y. Okay, so we have found r and we have found theta. Cos x plus iy, where we can use r and theta. We already know that r cos theta plus I sin theta. We know r, we know theta, but we can simplify it further by saying cos theta plus I sin theta can be written as r times e to the power of I theta, right? Now let's take log on both the sides. So log of cos of x plus iy is equal to log of, when I say log, remember, to the base e of r times e to the power of I theta, right? And to this I can add 1 in any form without changing its meaning, so, or a value. So e to the power of 2n pi I multiplied. Okay, if you want to confirm it, let's very quickly do this. E to the power of 2n pi I is equal to cos 2n pi plus I sin 2n pi. Okay, now 2 pi is what? Is 1 cos, and this is 0, so we end up with 1. So we are multiplying it by 1, which means it is not going to change its value. Okay, so now let's apply logarithm rules. I can say log e of r plus log e of e to the power of I is common, 2n pi plus theta. Now log and e cancel out each other. We are left with log e of r plus I times 2n pi plus theta. Okay, now let's look here. We know what is r, we know what is theta. So let's do the substitution. So we end up with log e of cos of x plus iy is equal to log e of r is what? That is 1 by 2 times cos 2x plus cos 2y to the power of 1 by 2. And remember, we have to write log. So log of e plus I 2n pi plus theta. Theta is what? Theta is minus tan inverse of tan x times hyperbolic tan y. So let's finally write this. So log e of cos of x plus iy is equal to, now 1 by log rules, 1 by 2 can be brought down. So 1 by 2 log e of 1 by 2 times cos 2x plus hyperbolic cos 2y plus I times 2n pi minus tan inverse of tan x hyperbolic tan y. Okay. See here, the thing is, you have to remember certain things, certain techniques. Say, for example, you need to know that, sine or cos can be written in the form of cos theta plus I sine theta, right? Then you also have to remember the appropriate, identities. For example, sine square x can be written as 1 by 2 times 1 minus cos 2x. And accordingly, cos square x is equal to, in this form. Similarly, hyperbolic cos, hyperbolic sine. So you need to know these identities and basically where to apply it. Okay. And another thing that you have to remember is, that cos theta plus I sin theta can also be written in as e to the power of I theta, right? So that comes through practice. As you keep solving problems, initially you will be doing it, maybe by watching somebody do it, for example your lecturer, or if you are practicing it, you will just maybe look at the textbook and do the solved problems. But as you keep doing it, patterns will emerge in your mind, and that is why this practice is very important. Okay, I think that's enough. Bye.